Okay, so I'm Mr. Piney, and I'm one of the three teachers that's going to try and teach you 3-digit by 3-digit multiplication. For our multiplication here, we're going to be using this giant shipping cargo ship, ocean liner, to study multiplication. As you can see, there are many containers on the ship, okay? And each container might contain a certain number of boxes. So let's take a look a little closer at our problem. A cargo ship carries 135 shipping containers. Okay? So each one of these little things right here is a container. Each container holds 487 boxes. How many boxes are on the cargo ship? So in each one of these little things, there's 487. Okay? So in other words, each really is a clue word to multiply. Alright? So here we go. I'm about to show you 3 different ways that you can multiply 135 times 487. The first one I'd like to try out right here is called the standard algorithm or the traditional algorithm. So here we go. So I want to show you 135 times 487 using the traditional algorithm. Okay? So I'm first going to look at the ones, and I'm going to color code this just to keep it separated. There's a 7 in the ones place, so what I'm going to do is I'm going to multiply the 7 times 135, which is essentially comes from the distributive property. 7 times 5 is 35. Regroup the 3. 7 times 3 is 21. Plus 3 is 4. Regroup the 2. 7 times 1 is 7, plus 2 is 9. So 7 times 35 equals 945. Now I'm going to move over to the tens place, in which I have an 8. So what I'm doing now is I'm multiplying 80 times 135. Okay? So 8 times 5 is 40. Oh, I almost forgot. Since I'm multiplying by a 10, I'm going to hold a 0 in the ones place because anything times 10 has a 0 at the end. So I'm going to put it there right in the beginning. On the far right, place value is a 0 anytime you're multiplying by tens. So 8 times 5 is 40. Regroup the 4. 8 times 3 is 24. Plus 4 is 8. Regroup the 2. 8 times 1 is 8, plus 2 is 10. So 80 times 135 is 10,800. Alright, moving right on over to the hundreds now. Because the 4 doesn't mean 4, it actually means 400 times 135. Okay? Since I'm multiplying by hundreds, I have 2 zeros, so I'm going to put 2 zeros to hold that hundreds place intact. 4 times 5 is 20. Regroup the 2. 4 times 3 is 12. Plus 2 is 14. Regroup the 1. 4 times 1 is 4. Plus 1 is 5. Now what I need to do is add those up. By the way, 54,000 is the answer to 400 times 135. Okay? So now I need to add up my 487 times 135 to get the full answer. 5 plus 0 is 5. 4 plus 0 is 4. 9 plus 8 plus 0 is 17. Regroup the 1. 1 plus 4 is 5. and 1 plus 5 is 6. 65,745 boxes are on my cargo ship. Okay? Now I want to take you into another form of multiplication. It's called lattice. So here it comes. So 135 times 487. 135 times 487. And actually, I think what I'm going to do is I need to spread that 135 out a little bit. All right. This strategy is called lattice. So what you do is you build a lattice. If you look up lattice on the internet, you'll see what they look like. And then you divide each digit with a line. So I'm dividing the 1 and the 3 right now. Now I'm going to divide the 3 and the 5. I'm going to divide this 7 and this 8 with a line across, this 8 and this 4 with this line across. So now I end up with 9 boxes. 3 across for the 3 digits across the top, and 3 down for the 3 digits along the side. Now I need to create my adding place value slides, which is done by connecting the diagonals of each box. Okay, and you can do it separately, like you can do it one at a time, just as long as the diagonals get dissected and it goes through each corner. That's the most important part. If it doesn't go through each corner, it's set up incorrectly, and then you're going to have mistakes. Okay? Now, one nice thing about lattice is it really just boils things down to math facts, and you just start entering math facts. So in this box right here in the bottom right, I look to the top and I see 5. I look to the side and I see 7, so I know that that's 35. I place the 10s above the slide and the 1s below the slide. And then I'm just going to keep going. So in this box right here, up above is an 8 to this, or a 5, to the side is an 8, 40, the 4 goes above for the 10s and the 0 goes below for the 1s. Now I'm in this box, 5 times 4, 20. Look above this box, I see a 3. Look to the side, I see a 4, that's 12. Okay, in the box in the middle, look above, I see a 3. Look to the right, I see an 8. 8 times 3 is 24. The bottom middle box, look above, I see a 3. To the right, I see a 7. Answer is 21. 3 times 7. The bottom left, I look above, I see a 1. I look to the right, I see a 7. 0, 7. The middle box on the left, above a 1, to the right an 8. 0, 8. Top left box in the final box, above a 1, to the right a 4. 0, 4. Okay? Now I talked to you earlier about these green slides. And what they are is they hold the place value of the addition together. It's almost like you're adding diagonally. And that's exactly what we're going to do right now. Okay? We're going to check out these. So underneath this slide right here, I have a 5 all alone, so that remains in the 1's place. Then I'm going to add the 10's place here, which is 0, 3, and 1, or 4. Now I'm going to add 7 and 2 is 9. Plus 4 is 13, plus 4 is 17. And I have to regroup a 1, so I'll put it over here in the next slide over. Okay? This should look more like an 8. 1 plus 8 is 9, plus 2 is 11, plus 2 is 13, plus 2 is 15. Regroup the 1, and I get 65,745. There's just one last way that I'd like to show you how to multiply 487 times 135. And that is by thinking of it as a rectangle. So if I were to take all of those containers and line them up, and I had 487 and 7 containers all lined up. And then I pulled out the boxes, and there were 100 boxes, 30 boxes, and 5 boxes in each column. What I'd end up with is something that looks a little bit like this. And I would end up dividing up my rectangle to sort of match up with how big each thing was. So I end up with smaller rectangles, like 9 of them. And if I look at the top of this rectangle, I can see that this one right here, in fact, I'm going to do this in red. This one right here is 400 wide, and it's 100 tall. And the reason I know that is because if I look over this way, I see 100. Okay? And if I look up this way, I see 400. It's just a smaller rectangle inside of my big, huge one, which represents my total problem. Okay? So since there's 400 across the top and 100 along the side, these are the dimensions, 400 times 100, that go inside of this red rectangle. Okay? I'm going to move down to the next red rectangle, and I know that there's still 400 across the top, but this time along the side, I look over here and I see, oh, it must be 30 tall. So it's 400 times 30 inside of this rectangle. And then over here, I know that it's 400 across the top times, look to the side, 5. So this must be a 400 by 5 rectangle. Okay, now I want to move to the middle here, these middle rectangles, the green ones, okay? So above here, this is 80 long. It's 80 wide, and across the side, or up and down ways, this way there's 100. So what I'm going to do is in that box, I'm going to multiply 80 times 100. Underneath, it's still 80 wide, and it's 30 tall because of what it says over there and above. So 80 wide by 30 tall. And then the last green box at the bottom is 80 wide by 5 tall. So in here I'm going to write 80 by 5. I have one set of squares left. Over here on the right hand side, I can see that up above I have 7, to the right I have 100, so that means that this is a 7 times 100 box. The middle box here, again 7 across the top times what's on the right, it's 7 times 30, and then at the bottom I have 7 times what's over here on the right, 5, so it's 7 times 5. Okay? Now, we've taken a really big problem and broken it down into smaller pieces. Now it's time to calculate each piece. The nice thing about doing it this way is you bring it down to just a matter of math facts and zeros. The math fact over here in 400 times 100 is 4 times 1. So I'll write 4, and then there's 1, 2, 3, 4 zeros. So I'm going to put the 4 zeros down, and then I'll put my comma where it needs to go. Down below, the math fact is 4 times 3, which is 12, with 3 zeros, 12,000. 4 times 5, which is 20, with 2 zeros, 2,000. Now what I can do is I can add 40,000 plus 12,000 plus 2,000 to find the total of just these 3 boxes. So 40,000, 12,000, and 2,000. I'm just adding this up now. So I get a total of 54,000 for those 3 boxes. All right. Now I'm going to move over to my 80 boxes over here. So 8 times 1 is 8, 3 zeros. 1, 2, 3. 8 times 3 is 24, 2 zeros. 8 times 5 is 40, 2 zeros. Okay, so now I'm going to add those. 8,000 plus 2,400 plus 4,000. Oops, this should be 400. This is not 50, it's 5. Hopefully you caught that. I knew something was wrong there. Okay, now that we got that straightened out, 10,800 is the total for the green 80 boxes. I wonder how many of you were screaming at the computer just now, telling me that I was wrong about 80 times 50. Okay, now to the blue boxes. 7 times 100 is 700, 7 times 30 is 210, and 7 times 5 is 35. So I need to add 700 plus 210 plus 35, 5, 4, 9, 945. So now I've got those three totals, and the last thing that I need to do is put those three totals together. So that's what I'm going to do now. 54,000 plus 10,800 plus 945. Let's add them up. 5, 4, 17, regroup the 1, 5, and 6. 65,745 boxes on the ship. 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 Those are 3 ways for you to try and solve a 3-digit by 3-digit problem. Watch it again if you need to. Ask questions if you need to. Good luck.